Solubility. Okay, so I'm just going to do problem number 1 with you guys from the lab today. So I'm just going to write it out up here first. And this is just kind of combining all that we've been learning on predicting reactions with solubility rules. So you also need that solubility chart posted on that November 9th assignment. So on number 1, we've got this right here. Plus Na2CO3, right? And part A says predict the formulas for the products of this reaction. So for whenever you predict the formulas, I had some confusion in the previous period. You don't look at these subscripts or try to carry over subscripts. You rewrite it based on the charges that they have, right? And so what products do you guys expect this to happen? What type of reaction would y'all say this falls under of the 6 types? There are 6 types of reactions. What does this fall under? Exactly. Great job. Double replacement. If you guys can't recognize that at this point, you guys need to come to tutorials and review how to predict types of reactions just based on this, right? That would be, you would have to know that, okay? So because there are 2 separate compounds, we know this is going to be a double replacement. So they don't all just swap with no order. The positives rearrange to form with the other negative, right? The cation and the anion. So this is a cation and this is a cation. They're going to swap partners, right? And so now the lead is going to be with what? Yeah, it's going to be with the carbonate, right? So when we write this, it's not just PbCO3. We have to figure out the charges. So what charge does lead have? How do we figure that out? So lead is one of those ones that acts like a transition metal. It's technically not in that transition metal group, but lead and tin both act like transition metals. So we have to figure it out, right? So based on this over here, we figure out what charge it should have. So let's look at this. On your polyatomic ion sheet, we have to work backwards. So what charge does nitrate have? The NO3 group on your ion sheet, what charge does that group have? -1. Y'all should all have your polyatomic ion sheet out, like the periodic table, right? Okay, -1, but there's 2 of them, right? So what's the overall charge on this side whenever there's 2 of them? -1 times 2, so -2, right? So what charge does lead have to have? +2. So most of the time, you can look at what this subscript is, but that's not always the case. And so I want you guys to know, like, okay, we look up the charge of nitrate, right? And multiply it times however many are there. There's 2, and so it's -2. It does happen to be the same as this one, right? It's the crossover rule. So lead has a +2 charge. I'm going to put that up here, right? Now we know that, and now we need a charge of carbonate. What charge does carbonate have? -2, great job. Okay, so because it's the same number, it can cross out, right? We don't have to do the crossover rule because 2 and -2 cancel out to 0, and that's what we want. Positive and negative, things always bond positive and negative. So you wouldn't have 2 positives. You would have a positive and a negative. If not, then something is wrong because lead is positive, right? It would never bond with sodium with the +1 charge. Like those 2 don't bond together. Positives bonds with negative, if that makes sense. So this is the way that you do it. If you're not looking at the charges and crossing over, you're doing it wrong. You might happen to get 1 right, but it's not going to help you long term for the test. And so now we need to do the other 2. So we're looking at sodium, and what does sodium bond with? Yeah, it's going to bond with the one that's left over, right? The NO3. So we need to look up each of their charges up on the top. So what charge does sodium have? +1. And what about NO3? Yeah, we figured out over here, right? If you look on your ion sheet for nitrate, for NO3, it's -1. So lucky for us, that one crosses out too, right? So and I'm going to scoot them closer together now. So you should be writing with pencil, right? NaNO3. So now that we know that, for part A, it says predict the formulas for the products. So your answer would be this one and this one, right? And then it says name them, right? So I'm not going to name this for you guys, but remember that there's covalent and there's ionic and there's also acids, but we're not dealing with an acid here, right? So ionic bonds have a metal in them, and covalent bonds have no metals, right? So, and remember that covalent bonds have prefixes that you add to them, right? None of these are covalent though, right? Because lead is a metal and sodium is a metal. So we're ionic, you change the ending to "ide" unless it's a polyatomic. I'm just kind of reminding you guys of this, right? So for example, carbonate doesn't change to carbonide. It's just carbonate. Nitrate is just nitrate, right? And then use Roman numerals for transition metals. So which one of those are we going to use Roman numerals on? What's that? Yeah, the lead, because it acts like a transition metal. And what charge did it have? +2. So you know what Roman numeral to do with the lead, right? So that's a reminder of part B on how to name them. Part C just says to balance it. You write the whole equation and you balance it. Like there are 2 sodiums here, and so I need to put a big 2 here, right, to make this balance out. Remember that with balancing, you can't change the subscripts, only the big numbers in front, which are how many molecules you have of it. So I can put a 2 there, make sure everything else is balanced out. There's 2 copies of nitrate, but I put a 2 right here, and then double check everything else, right? And then it says circle the product or products that are precipitates. So what we'll do for that is we need to go to our solubility chart. It was posted on November 9th for the virtual students, but you guys all have your physical copies of it. And we need to figure out which of those 2 products are going to be soluble or insoluble. We need to circle the one that is not soluble. So let's go look at it. We're dealing with lead carbonate and sodium nitrate, right? So when we look at this group, nitrate is always soluble. So the nitrate one is not going to be circled, right? So let's look at the lead carbonate. I don't see anything on here for lead or carbonate. Oh, but I see carbonate right here. So carbonate compounds are always insoluble except when in solution with group 1 or ammonium. Is lead part of group 1? No, so it's going to be insoluble. So it will not dissolve. And so you're going to circle that one because it says circle the product or products that are precipitates, right? Precipitates means that it's insoluble, that it's a solid, right? So I did number 1 with you guys to kind of give you all a glimpse of what you're doing, but there are 9 more problems like that. Part B says name the product. So I kind of reviewed with y'all a little bit of naming. So y'all need to remember that yourself and kind of look at that. I can leave it up for y'all if you want right here to see it. But y'all should know how to name for the most part for them. Review your naming rules as well if you need to. What's that?
And then circle the product?
Yeah, so for part C, it says write a balanced equation and then circle the product or products that are precipitate. So you need to balance it as well and then circle the product. And that's all that this is. And then y'all are going to actually do your lab. So before the lab, do y'all have any questions on any of this? Does that make sense, what you're doing? The papers from yesterday are practice. You needed to turn in the predicting products of reactions. That was due on Friday. So if you turn it in now, it's late, but I'll accept it. And then
I know the past you've taken some practice grades, it's like actual grades, so those people worksheets.
Wait, I'm sorry.
I know in the past you've fixed some practice papers that have been counted as actual grades.
Yes. So like whenever it says practice, it doesn't always mean that we're not putting it in the grade book, but the work from yesterday is not going to be put in the grade book.
Okay.
The work that y'all turned in on Friday will be put in the grade book. Okay. Any other questions on that? Okay, hold on.